Lab 3, Black Hole and Orbits. Introduction. The purpose of Part 1 of this lab was to find the mass of the black hole, and the purpose of Part 2 was to make our spaceship move around the moon and planet. The main physics principle we're looking at in both of these is Newton's second law, as we are analyzing forces and momentum. Systems and surroundings of Part 1. The system includes a star and a black hole, while the surroundings include nothing. Code Part 1. First, I input my email to get a randomization for a trajectory value. Then I input the mass of the star to be 2.0 E30 that I was given, and then I changed the delta D to be 1 day in seconds, and that was also given to us. Then, as we can see in my code, I input the initial values for momentum and final values, and then initial and final for delta V and delta P, and then I calculated it for the parallel and for the perpendicular forces of the momentum, and then using Newton's second law, I was able to get MBH, which is the mass of the black hole, with Newton's second law. And at the end, I summed it all up and divided it to average it. Here are my results for Part 1. You can see it's just the star orbiting around a black hole. Systems and surroundings of Part 2. System includes spaceship, planet, and moon, and the surroundings we assume includes nothing. Code for Part 2. To make the spaceship move around the moon and the planet, we found all the forces acting on the moon and the ship. So we are getting the F net on the moon and F net on the ship. Then after that, we are updating position and velocity and updating those forces based on those and getting new net forces until the end of our time interval. So here we can see that we're doing iterations. So if we start at the top of my code, I find the position from the planet to the moon, and then I find the force from the planet on the moon, and then I do those same two for the ship to the moon and the ship on the moon. And then I calculate the F net on the moon. And then I do that whole same thing, but for the forces on the ship. And then at the end, we can see because of Newton's second law, I update that velocity and position, and then because of that, they go through the iterations. Here are my Part 2 results. After that, there was a lot of trial and error to get the speeds right so that the spaceship would fly around both the moon and the planet instead of going off into space. But in the end, these are the numbers I ended up with. So I got the speed of the ship in the X direction to be negative 28,600 and in the Y direction to be 25,600. Reasons for error. The reason for error, for one, is that for the speed of the spaceship that I was just plugging in random numbers and seeing if they gave me the result I wanted. So this is human error, and there are definitely some better options to get it to orbit how we really want to. Also, another error might be that we made some assumptions along the way, like the systems and surroundings, because I didn't count for anything that they didn't specifically mention. Additional questions. So what does this mean for Part 1? While net force and the change in momentum are mathematically equivalent, it doesn't mean that they are the same to implement. Momentum is easier to use because we only need the change in the object's velocity and position, while for net force you need to know every single object and their forces / the components to make up a force. What if the Part 2 system also had a black hole in it? So in Part 2, the moon orbits around the planet. But if there was a black hole, everything would orbit around the black hole instead of the planet because its mass and thus force is so much stronger than the others. Thank you.